I'm Curtis Brown from Texas Instruments, and I'm here with Esther Brunat, and she's a high school math teacher from South Florida. Super excited to have you here, Esther. Today we're doing a smart space video for parabolas and hyperbolas. We're going to be introducing and talking about parabolas and hyperbolas and developing those equations. So Esther, can you take it away?
I'm gonna take it away. Okay, so parabolas and hyperbolas, again, for no reason at all. I just made these spin across the screen. Just as a attention getter. Here we are.
They're so much fun.
Okay, I like it. So hyperbolas, so we have two different types of hyperbolas. They can either open up and down, or they can open left and right, okay? That depends on our a values, right? So I have x minus h squared minus, well, over a squared minus y minus k squared over b squared equals 1. So very similar to the equation of an ellipse, but there's a minus in the middle instead, okay? But we have certain parts that we want to talk about. So we want to talk our h and k is our center. And then we have our axes so we have our a value, and then we have our b value. So the a value is our blue, and then the orange value is the b value. Okay, so if we're talking about when they open up and then when they open down, something very similar happens, right? We still have our h and k value, which is our center. Hey. And then we have the blue value being our a value, and then our orange value being our b value. So that's the equation in a nutshell, okay? And we're gonna notice that where the a value is depends on under which variable the a value is, depends how the parabola opens up, right? So if it is under the x value, then it's going to go left and right. And then if it is under the y value, it's going to open up and then go down. So knowing all that information, and also knowing how transformations work with an h value and a k value, I'm about to put Curtis on the spot here, right? So this is our equation. I have x minus 3 quantity squared over 16 minus y minus 1 quantity squared over 36 equals 1. So what Curtis is going to do is he's going to evaluate this equation and tell us what the center is and what the a value is and what the b value is.
All right. So first of all, I can put us on the center. Like we can look at this. We've been talking about h's and k's. We've got transformations going. Like we got that part. Like h and k. So h being 3, k being 1. Noticing that this one is going to be the center of this hyperbola is going to be translated 3 units to the right and up 1 unit from 0, 0. So that's at the point 3, positive 1. Got that. All right. So now let's actually talk about this just a little bit. I noticed that I have x minus h is the leading piece of my equation here. So this equation or this hyperbola is going to be opening sideways like this because x minus h is going over the a squared value, right? So it's the leading coefficient. I'm not subtracting on this one, so I got the horizontal orientation on this one. Now, since a squared is 16, a is going to be 4, all right? And so that's going to be defining the smaller chunk of that little rectangle that you were showing us earlier, all right? And then b is going to be 6 because b squared is 36, so I can take the square root of 36, and we'll see that the longer piece of that rectangle that you were defining earlier is that 6, all right? And then if I was going to draw asymptotes in between here, it would be the diagonals of that rectangle that you just got drawn for me right here, all right? So I could draw in those asymptotes, and that gives me kind of the way that I approach this hyperbola. How'd I do?
You did fantastic. 17 gold stars for you.
Right. I do notice something here. I do notice I can actually look at the slopes of those asymptotes and get those from A and B, right? I can see that my slopes of my asymptotes are going to be, what is that, 6/4, 3/2, and -3/2. So I can draw those in
That's our rise over run.
from A and B.
Look at that. I had a feeling that you were going to tie the slopes into it, even though it doesn't say anything about that. But I was like, he sounds like a slope guy to me, so he's probably going to agree with that.
That's exactly right. Like, you got to talk about that rectangle and seeing that rectangle happen, right? So that's super important.
It's true.
We start talking about how we're going to work backwards.
Exactly. Okay. So speaking of going backwards, Curtis, now on the screen, we have a hyperbola, and it's going to be your job to figure out what this equation of this parabola is going to be. Hyperbola.
All right, so first of all, thank you again for the equation on the left-hand side over there in general form, because that helps me out tremendously. I can see, but I can see that this is a vertically opening hyperbola, and so I should expect that I have y minus k squared over a squared in the front, and then x minus h squared over b squared being subtracted, right, equals 1. So that's I can go from that, I can build from that. So let's start off with finding the center. If I look at my intersection of the two asymptotes, I can see that the center seems to be at 3 units away from the origin in the x direction and 0 units up or down. So I'm going to say that my center is at 3, 0, which means that h is 3 and k is 0, right? All right, so that's where the center is. Now, I can either use the dimensions of this rectangle that you've kind of got in there in dotted lines, or I can just look at the slopes of the asymptotes. I like to look at the slopes of the asymptotes. So coming in the upper left-hand corner there, I can see that I'm going down 2 units and then right 7 units. So I'm going to say that the slope of the first asymptote is -2/7, which means the slope of the second asymptote is +2/7. That gives me that my A is going to be 2, like that, 2. All right, and then my B is going to be 7 units, all right? So that means that my equation should look like y minus 0 squared, or just y squared, over 40, or sorry, over 4 minus x minus 3 squared over 49 equals 1. Whew.
Whew. You need to break a sweat.
Well, you can't see it, but it's happening. It was right here.
So great. Okay, so those are hyperbolas. So then we have our last conic section, right? We are going into parabolas.
I love parabolas.
We love parabolas. I do too. So when we're talking about parabolas, we spent a lot of time in Algebra 2 talking about parabolas as quadratics, right? And now we get to talk about them as conic sections and what are some of the properties that are going on there. So when we're looking at parabolas as conic sections, we can have them open up and down, or we can have them open left and right. So we always have our HK, which is going to be our vertex of the parabola, right? And then we're going to have our p-value. Our p-value is actually the distance between the vertex and the focus, okay? And it's equidistant from the distance between the vertex and the directrix. So if you look at those little orange lines, there's 2 different types of orange lines, so that you know that those are equidistant. So then the same thing happens if it opens up and down. I have my H and K. And then I have my p-value, which is the distance between the vertex and the focus, or the distance between the vertex, which is the same as the distance between the vertex and the directrix. All right. We have our H and K, Curtis. We have our p-values, okay? Yes. So again, I'm going to challenge you. Given an equation, x minus 3 equals 1/8 parentheses y minus 2 squared, okay? We need to figure out what the vertex is and what the p-value is, okay? And you also have to determine which way we're going. Are we going up and down, or are we going left and right? Ooh,
Oh
tricky,
my
tricky.
goodness. Oh my goodness. Okay, so a couple of things we can do here. First of all, I'm going to look at the equation there and see that y is squared. Okay, and so since y is squared, that tells me that this thing is opening horizontally. So I'm relating x to y squared, right? So I'm going to see
Absolutely
values for y for any x that I got in here, right? So that's going to give me a horizontally opening parabola. Now I can also see this one doesn't have a negative in front of it, so that's why I did it this direction, right? So on the screen, that's what
yeah,
it shows there. Okay, so all right, I've got
very
that.
good, very
All right,
good.
horizontally opening. Now the next thing that I can see is that h and k are negative, or sorry, positive 3 and positive 2. All right, so I've got 3 and 2. So my focus for this particular one, or sorry, my vertex for this particular one is at 3, 2. Right, so I'm going to go up 3 units, or sorry, right 3 units. Man, I almost am screwing this one up really bad here today. All right, so I'm
No,
going
you got this. You got this.
and then up 2 units. All right, vertex. All right, so now you tell me that I've got 1 over 4p is 1/8, which tells me that p has got to be 2. Now you want to go a little bit even further, is that we can say that, okay, if p is 2, this is opening horizontally, that means that my vertex is going to be at the place 5, 2, right? I'm going to be 2 units to the right of that vertex. And then my directrix is going to be at x is equal to positive 1. All right, so that tells me
nice.
units to the left of 3. So there's my x equals positive 1. There's my parabola with the focus at x is equal to positive 5 and y is equal to 2.
Well done, sir.
Man, I'm telling you, I got my tangle tangled up right there early on in the beginning of that, but I got it done.
You still landed the plane. You still landed the plane.
Yeah.
Okay.
Yeah, there was
so
some
now,
turbulence, but we got it done.
So now you know what's about to happen, right? Like we got the equation and we put it on the graph. So
now you're gonna tell me to equation that graph, right? All right.
Yes.
All right. So here we go. We're gonna equation this graph. Now I notice right away that this one is opening vertically. I notice that I can kind of relate that to the equation because I've got x squared and y related. So I've got y minus k and I've got an x squared term in there. So I know this one is definitely opening vertically. And since I don't have a negative sign in front of it, I can also say that it's opening positive. So it's like a little smiley face like this. All right, so I've definitely got that going on there. Now, next, I can kind of start trying to decipher this just a little bit. I'm first of all going to start with the vertex. Vertex is fairly easy. I can see it as 2 units to the right and 1 unit up from the origin. So that means that my vertex is at 2, positive 1. H is 2, k is 1. Okay, so in my equation, that's where I'm going to get the 2 and the 1. And then I can figure out p. You've given me the focus up there at 2, positive 1, 2, 3, 4, 5, 2, positive 5. All right, so my p value here is going to be 4 because my vertex is 4 units below that focus, and that means that my directrix is going to be 4 more units below that, right? So p is equal to 4. That means my equation is y minus 1 equals 1/16 times x minus 2 quantity squared. My equation for my directrix is y equals -3, and my focus is at 2, positive 5, 2, 5.
Look at you with the extra credit. I love it. I love it. Flawless, sir. Absolutely well done, as usual. So we have our parabolas. Now, parabolas are fun because parabolas actually, like in nature and just their applications that we can use. So we're going to talk a little bit before we wrap up about parabolic microphones. Okay, so I have a little picture here, And then I have a little diagram of what actually happens with a parabolic microphone, but I'm going to let Curtis explain because he's so good at this.
No, so
What
it's
exactly is a
so
parabolic
way
microphone?
cool. It's so way
I
cool
agree.
about the angles that things come in and they reflect at on a parabola. It's the really neatest thing that all of the values coming into a parabola, if they come in, say perpendicular to the line that kind of connects the vertex and the focus, all right, they're going to come in and they're going to all come in and bump into that that focus, right? And so it's really cool that parabolic microphone is actually focusing all of the sound that's coming into that shield there, that clear shield that the guy is holding there, is in the shape of a parabola. And the microphone is actually placed at the focus of that parabola so that all of the sound is being focused right directly into that microphone. And it really kind of amplifies everything so we can hear it a lot better. That's why you'll see those guys doing that on the football field. They can hear things from a long distance and all kinds of things like that.
I love it. Curtis, do you know who created the microphone?
I have no idea, but I bet you're going to tell me.
I am. James Edward Maceo. He created the microphone. And do you know how many microphones are made in a year?
In a year? I don't know. 1 million?
1 billion microphones are made every year. Isn't that crazy?
Incredible. I had no idea that there was that many microphones being made every single year.
You know, they're in our phones. So I feel like that's probably why that many are made.
I guess so, because everybody's got a phone that they're holding on to, or earpiece that they're holding on to. In fact, I have 3 microphones right here in my little room here. I've got one on the table for this podcast. I've got another one on my camera, and I've got another one on my computer. So yeah.
Oh my goodness. You can't go wrong with that. So that's it. That is a conic section. We just finished our episode, our lesson on parabolas and hyperbolas. And this has been so much fun.
Yes, this was really great. Thank you so much for doing that, this section and all the visuals that we had on there. It was awesome. So thank you very much, and we'll see you.